So last week we started looking at our arithmetic sequences and series. Today we're going to continue on and look at geometric. Our geometric are very similar, but for our arithmetic, they add something each time. Okay, for our geometric, we're going to multiply by something each time. So it is a sequence. Where each term is multiplied by a constant to get the next one. In general, we call this constant, we're going to call it R. And the reason for that is because we're multiplying the same thing each time. So if I wanted to figure out what that constant is, I can divide two of my terms in order to find it. So they call it the common ratio. So that's why it's R. Just like with our arithmetic, we have a general formula, and that is a sub n equals a sub 1 times r to the n minus 1. So our geometric is going to be exponential. So our n is in the exponent. Versus, remember, our arithmetic was linear. So remember, your a sub n is just the nth term. Your a sub 1 is the first term. And then your r is, again, that common ratio. Also remember, I will be giving you the formulas on your test. But you do need to know, which thing is what, right? You need to know what a sub 1 is. You need to know what r means. Those types of things. So let's look at an example. So it says write an equation for the nth term of each geometric sequence. So we're just applying our formula from the previous page. So on our first one, what is our first term?
0.5.
Yep. And then what's our r? So like what am I multiplying by each time?
4.
Yep. So then I have 4 to the n minus 1. And that's our answer. So because the n is in the exponent, we can't simplify that any further. So like that's to simplify this again.
How do you find the R again?
So I can take any two of my terms and I'm just gonna divide them. You just have to do the like later one divided by the previous one. Okay. Now in our next one they just give us R, so that's nice. What's the problem though?
We don't know A sub 1.
Ah, okay. So what can I do? Do they give us anything else? Bless you. What do they give us?
The 4th term.
The fourth term, okay. So if I have the fourth term, and I want to go backwards, right? So to go forwards, we multiply by our R each time. So what would I do to go backwards? Divide. So how many times would I have to divide by 6 in order to go from the fourth term to the first term?
3.
So I'm going to take my fourth term, and I'm going to divide by 6 3 times. So you could either do like 5/6, which is one time, and then do it another time, and then do it another time, or dividing by 6 3 times is also the same thing as dividing by 6 to the third. So what is 6 to the third? Anyone know?
5 over 216.
It is 216. So then that is my first term. And that would be our equation. Maybe. What questions do we have? So if I want to identify if something is arithmetic or geometric, we need to look at our numbers that we have. So on the first one, what does it look like we are doing? Minus 4. So if I'm minusing 4, is that arithmetic, geometric, or neither? Yeah, because we are adding a negative, but it's still adding each time. Alright, what about our next one?
That'd be geometric.
Yeah, because we're multiplying by 3 each time. What about our next one?
Geometric.
Is it? So like to get from 3 to 12, we had to multiply by 4. But to get from 12 to 14, did I also multiply by 4? No. To get from 3 to 12, I could also add 9, but did I add 9 to get to 14? No. So it's neither. There could be like some sort of rule, we just don't know what it is, but for us, like we only care about the first two. Now the last one looks a little funky, so we have to decide. So basically it's saying that a sub 0 is 2, so that's my first term. Then after that, I find my next terms by multiplying the previous term by 5. Right, so a sub n plus 1 means the next term. A sub n then is the previous term. Yeah, because I'm taking the previous term and multiplying it by 5 each time. Yes, no, maybe? It's going to be important if I tell you to like find the sum or find the something term or whatever, you need to be able to identify, is this arithmetic and I want to use those formulas, or is this geometric and I need to use those formulas. Now, we also have geometric series, so those are just the sum of the terms of a geometric sequence. So I turn it into a series by adding all of my terms together. So this is the nth sum, so S sub n equals my first term times 1 minus r, so remember r is our ratio to the nth power, divided by 1 minus r. Alright. So what do we have here? What type of notation is this? It's our sigma or our summation notation. And what about the inside of that tells me that this is a geometric sequence, or sorry, series?
The 4 is multiplied by 2.
So not necessarily that it's multiplied.
There's a thing in the exponent.
Yeah, we have an exponent. So if it was an arithmetic, remember it has to be a linear equation. If it's geometric, then it's going to be an exponential. So my k minus 1 is in the exponent. So that's what tells me that it's a geometric. Because remember, this just means that I'm plugging in, so starting at 3, and then I'll plug in 4, and then 5, and then all the way till 10, and I'm going to add all of those together. So you could do it the long way and plug those in and add all of them together, but that's just a lot of like typey. Also, like, I'm not going very high here to 10, but if we were going to like 57, right, we wouldn't want to plug all of those in. So we want to identify that it's geometric, because then that tells us that we're using our geometric formula that I had on the previous page. And then you just have to decide, okay, what is our n? How many terms are we adding up?
Seven.
Where did we get 7 from?
Because we're starting at 3 and ending at 10.
So if I do 10 minus 3, I agree that that's 7. And that's how many more terms after 3 it's going to take me to get to 10.
It's 8.
It'd be 8, because then I also had to plug in 3. So it's always going to be top minus bottom plus 1. So I get 8. So we have S sub 8 equals. Then be careful, because remember, my first term is not the 3. Okay, my first term is what I get when we plug in 3. So 3 minus 1 gives us 2. 2 squared gives us 4, and 4 times 4 gives us 16. And then your R is just whatever is being raised to the power. So in this case, it's 2. And then we can just type all of that into our calculator. Just be careful that you use parentheses around the bottom part, or you can go ahead and type in 1 minus 2 to the 8th divided by, like click enter, then click divided by -1. Just so you're careful about your division.
So we just put the 2 because like that's what the 4 is multiplied by.
Yeah, whatever's being raised to the power. So like whatever has the exponent on it is your r. It's basically because you're multiplying it each time, it gets raised to a new power. So what do we get? Someone want to tell me? It is 4,008. Which seems rather large for only 8 terms, but remember that this is an exponential, right? And our exponential graphs get really big pretty quickly, and then we're adding those all together. So it makes kind of sense that I would have a relatively large number there. Alright, let's look at one last example. We're going to look at a word problem. Yay! So it says, Julie sees a new band at a concert. She posts a link for the band's page on Instagram. 5 of her friends see and repost. Each of them have 5 friends that repost. If this follows in the same pattern, how many people will have seen the post on the 8th round of shares? So let's think about, what is my A sub what? Or how many people shared it in the first round? Not quite. She's the only one that shared it at first, right? So like it would just be 1, yes? And then after that, yes, 5 of her friends shared it, agreed. But then as of A3, so the 3rd round, so our ends are basically representing the rounds, okay? How many people shared it in the 3rd round? 25. Because each of those 5 had 5 more friends that shared it, so it's going to be 25. So what are we doing to get to the next round? So if we're multiplying, that means that we have a what? Geometric. So my R is 5. Are we all okay with that? Because that's our biggest thing when we have a problem, is basically just deciphering what it is that I actually have there. And then we have to decipher what it is asking us to find. So it says, if this follows in the same pattern, how many people will have seen the post on the 8th round of shares? So is it wanting only the people from the 8th round? Like how many people are seeing it on the 8th round? No. It's wanting the everybody, which would be what? The sum of all of the rounds up until 8. So I'm looking for S sub 8. Now, if it said like how many people see it during the 8th round, or 8th share or whatever, then it would just be looking for S sub 8. Or sorry, it would just be looking for A sub 8, and it's just looking for that specific term. Here, it's wanting me to add them all together. So again, we're just using our formula. So what's our A sub 1? 1. And I have 1 minus, what did we say our R was? 5 to the 8th power. So I can just type in 1 minus 5 to the 8th. And then you're going to divide that by a -4. And what do we get?
$97,656.
600 and what?
56.
56. That's what I'm gonna do. Which is kind of a nice example of like how things go viral, right? Because like most people on social media have more than just 5 friends. So like if only 5 of each person's friends share something, like that's how quickly things can spread. Alright, what questions do we have there? Is it okay about geometric sequences?